Hey, 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 it's Dr. J, back again with another lesson. For those of you worried about the test, you'll be glad to know that this will be the last section before the test number 2. Okay, so you could be happy to know that we are almost done. So quadratic functions. Quadratic functions are any function that is a transformation of x squared, or y equals x squared. This is what we call a quadratic function. Now, we've already talked a little bit about these in the section on conic sections. We're going to take a slightly different approach to them. So in this section, or in this approach, we do not ask for the focus or the directrix or any of those other focal diameter. We're not going to ask for any of these conic sections details covered in the previous chapter where we learned about the conic sections. Okay, so you'll be good to know that we're not going to be doing that way. We are only concerned with, or mainly concerned with, I don't want to say the word only, we are mainly concerned with the vertex. Okay. So the vertex of a quadratic function. Well, let's talk about that. The graph of a quadratic function is called a parabola. And there are two basic types of parabola. We call this opening up. Called a happy parabola. It opens up. And we have this one opens down. There are more sophisticated terms like concave up and concave down. We're not going to get into those details in this particular course. All right? This is a survey course of just the general behavior of a quadratic function. So we're going to use layman's terms like opens up and opens down. The vertex is the lowest point when the parabola opens down. The vertex is the highest point where the was going to take up too much space. So I'm just going to say is highest point. You know what I mean. Here, I'll put it there. The vertex is the highest point when the parabola opens down. I realize I got the words up and down backwards. So when the parabola opens up, the vertex is the lowest point. When the parabola opens down, the vertex is the highest point. Now, there are other points on the parabola that I might ask you for later. In this particular presentation, I'm only going to ask you for the vertex right now. We'll get into the other points later. Okay. We have two forms of a quadratic function. I think of them more like heads and tails. You know, it's two different ways of looking at the same graph. The first form is called standard form. Standard form is y equals ax squared plus bx plus c. But you have another form called vertex form. These are two different ways of looking at the same problem. The same exact equation can be written in either vertex form or standard form. I should note that the letter y could also be written as f of x. All right. I will frequently go back and forth between the two notations. So I'll just put a little memory bubble up here. Throughout the lesson, in fact, throughout all of the chapters involving functions, y and f of x mean the same thing. Okay. The standard form is easy to write. Yeah, it's very simple to write down, but it's hard to see the vertex. Not possible, but it's hard to see what the vertex is. The vertex form is a little bit harder to write down, but it is very easy to see the vertex. The vertex is the opposite of the inside number and exactly the outside number. That sound familiar? I sure hope so. I think it does to everybody. Anybody that's done their homework from 3.5 and 3.6. So the inside number is opposite. So negative h becomes h, and positive k becomes positive k. We typically don't write the plus sign, but I mean, you could write plus k, but I think we all know that that just means k. Okay. So these are the coordinates of the vertex. Let's start with my first example will be in vertex form. Find the vertex. So find the vertex. I gave you a function that's already in vertex form. So this is your A. The inside is the H. And the outside is the K. So this is basically a free answer. Just read it off. The vertex is HK. So 4, 9. Remember, the inside number is opposite. The outside number is exact. Okay. OPP for opposite. It almost seems too easy, right? Well, let's try a couple more then. Let's just call that A. Let's keep this rolling. So how about f of x equals x plus 3 squared minus 5? The vertex is -3, -5. Hang on to these points. We might graph them, or they might not be the same numbers, but we're going to graph this point in a minute after I finish this example. I don't have to say f. I could say y. Y means the same thing as f. So where's the vertex? Notice the leading number doesn't tell us anything about the vertex. Okay. So it's the opposite of -5, which is 5. And then there is no outside number. So put 0. Yeah. If you have a missing term, if the k is missing, well, then that means it's 0. Yeah, so 5, 0. We got room for a part D. Another name for a function is g of x. Okay, there's no parentheses. Yeah. If there's no parentheses around the x, then that means it's 0. You can think of this as x minus 0. That's another way of saying just x. And then 6. Yeah. Notice the 6 is outside, so the 6 is the k, and the 0 is the h. So you've got your h and your k. 0, 6. So when I'm asking for just the vertex, the a value doesn't really contribute. However, the value of a, it's called the leader, or the leading coefficient. Leading coefficient is a mouthful, so we often just say the leader, determines if the graph opens up or down. So you have f of x equals a, x minus h squared plus k. If the leader a is greater than 0, then the graph opens up. If a is less than 0, then the graph opens down. The vertex is HK. So two problems might have the same vertex, H and K, but one of them might open down and the other one might open up. It's all based on this first number called the leader, A. It's also called alpha. And the word alpha is another name for the leader. Alpha goes first. Follow the leader. All right, so example 2. Find the vertex and determine if it is the highest or the lowest point on the graph. All right. So keep in mind, if the graph opens up, then this is the lowest point, because the graph is opening up. If the graph opens down, then it's the highest point. Keep that in mind. Go ahead and memorize that or write it in your notes, and then I'm going to erase it right now. So 1, 2, 3, gone. All right? Okay, now these are in vertex form, so the vertex is easy to read. Find the vertex. Yeah. Opposite of 5 and exactly -6. Okay. Now look at the leader. The leader is negative. Yeah. It's less than 0. So the graph opens down. So this is the highest point. It's the highest point on the graph right there. It's kind of important. If you think about the coordinates, in a minute I'm going to graph this, that means that no point on the graph is higher than -6. Right? And if you think about what a graph looks like, that's below the axis. So the entire graph lies below -6. All right. How about this one here? We got our vertex. Two and 4. Yeah, remember, opposite of -2 and exactly 4. Now look at the leader. Leader is positive. It's greater than 0. So that means the graph opens up. So the vertex is the lowest point on the graph. And again, if you think about this coordinate, 2, 4, that means the y value is at 4. The entire graph is above 4. You won't have any points that are lower than 4. You guys are going to love the way we do graphing in this chapter. You only need 2 points, and one of them you get for free, basically. You get the vertex. So I just want you to graph the vertex plus any other point on the graph. I mean, if any other point that fits in your window, of course. Let's go ahead and do one. Example 3. All right. In fact, I probably shouldn't be telling you this, but I'll give you a little hint. If you're behind on your homework, okay, the technique that I'm about to show you, you can go back to chapter 3 and do some of your graphs, as long as they're quadratic. So this is not going to work. This technique's not going to work for all the rest of the mother functions, but at least one of the mother functions, the quadratic, the parabola, which is pretty common. I'd say almost half of the questions are going to be parabolas. So, you can go back, and if you like this technique better, you can use this technique. It's a little bit quicker. It's a little bit more advanced. Turns out the more you know, don't tell anybody, the less you actually have to do. All right, so graph this thing. All right, I only need 2 points. The vertex plus one other point. And the vertex is essentially free. Yeah. The opposite of 4 is -4, and then exactly 3. Yeah. Hopefully you've got that memorized so you don't make silly mistakes right out of the gate. Okay. The -1/2 is telling me that it's negative, so the leader is negative. So the parabola is going to point down. So before I even do the problem, I already know in my mind that I'm going to get an upside down parabola. And I know this point is right there, -4 and 3. All right. So you just need one more point. Plug in any number for x, such as x equals 0, yeah, or whatever you like, your choice. All right, there's only one rule. You can't reuse the vertex again. So don't use -4 again. You'll just end up getting this point back all over again. You need to have a different point. So you can choose any value except whatever the vertex is, the x coordinate of the vertex. I don't think you would pick that number anyway. Hardly anybody says, oh, I'm going to pick -4. I love that number. I mean, you might be the one person that I just said never does that, but whatever. All right, so plug in 0. I usually do 0 or 1. Those are the two easiest numbers, okay? So you're going to get -1/2. Sometimes 0 doesn't work out very nicely. You might pick something else, but 0 works pretty good in this one. If you don't like what you're getting, if you're getting a fraction or a decimal or something, you feel free to change your mind. You just need one good point. So I don't want you to stick with a point if it's not working out for you. All of this should be just basic arithmetic. If you have to use your calculator, you can. So you're going to get -5. So these points go together. This is x and this is y. So x is 0 and y is -5. So you got 0, -5. And that's all you need. Okay. Just a little fun, in case I ask, this is called the y-intercept. You probably already knew that. Because x is 0. So if you choose to use 0, you automatically get the y-intercept. And that's it. We're done. So we kind of already know what we're going to get. We're going to get a graph. Y is 3. X is -4. And then 0, -5. Make sure you put it at the right -5. I have had students accidentally put it at this -5. So be careful. And there's half of your parabola. Then you have an invisible line going down the middle. This line is called the axis of symmetry. Okay, it's actually invisible. So you only draw it on paper. All right. So you will not see this line on a computer. It's only visible on paper. And what this does is it gives you, suppose I was covering one of my eyes like this. Because you know I'm a human being, I have an axis of symmetry right down the middle of my face. And so if I was covering half my face, like this, you would know what's on the other side. You know that I have an eyeball that you just can't see. So the same thing is happening here, right? You have another half of the graph that's going like this. And now you've got your full graph. I don't need any extra points. I need a minimum of 2 points to draw the graph. Okay, there is another point over here. If you want to draw it on paper, you certainly can. But you don't have to click there on the Canvas app. It just actually won't even let you. Once you've clicked those 2 points, you're done. All right. The axis of symmetry is the line x equals -4. We call that the axis of sim, or the axis of symmetry. It's this line that goes right down the middle. It's not actually there. So this is what it will look like on the computer. You won't even see that. It's an invisible line that cuts down the middle. You have one on your face, too. You have an axis of symmetry right down the middle of your face. You don't act, unless you tattoo your face or something, you don't really have that line there. Okay. All right. Example 4. Suppose we have the function y equals x squared minus 4x plus 1. Find the vertex. Sketch the graph. State the y-intercept and the axis of symmetry. All right, so after we're done with the graph, I'll state. State just means tell me what it is. State it. I can also say find or determine or illustrate or something like that. All right. Notice this equation is not in vertex form. It's in standard form. So that's a bummer. Yeah, it means you don't get to see the vertex very easily. Yeah. Or maybe you're not that sad. Maybe I'm being a little overly dramatic. You're just kind of like this. I wish it was in vertex form. So I'm going to show you how to rewrite this. Okay. So step by step. Y equals x squared minus 4x plus 1. I like to leave a little space right here. Subtract 1 from both sides, whatever the constant term is. It's always going to be the last term. Okay. You probably remember this from chapter 2. Take half of the middle coefficient. So half of -4, that's -2. Then square it. You could just do it right here, but I'm going to do it down here. -2 squared is 4. That's a coincidence. 4 is such a perfect square number that it always comes back to being itself. This only happens with 4. I'll do some more examples in a minute. And then you're going to add this to both sides. So we're going to add +4 and +4. So now I've got y plus 3, -1 and +4 is y plus 3. And now I've got x squared minus 4x plus 4. Just rewriting it because we're now moving back up to here. So now we're going to keep working. Now we're going to factor the right-hand side. All right, factor. It should be perfect. All right. If this factoring is not perfect, 2 copies of the same factor, then go back to here and check your math. You might have done something wrong. It's always going to be a perfect square. This process is called completing the square, so you always end up with a perfect square. Finally, you're going to subtract 3 from both sides, and you are done. There you go. If you don't see an A, there's an invisible 1. Yeah, it's invisible. You don't even have to put it. All right, I'm going to erase it now because in general, you won't see a 1 right there. But I leave it to my students. If you like having the 1 there, then put it there. Most of my students, if this were in a class, would say, they'd nod their head, or some people might even raise their hand and say, do I have to put the 1? And you know I'm going to say, no, you don't have to put the 1. But if you want to, you certainly can. It's your math. It's your equation. Do whatever you want with it. All right, so once we have it in vertex form, now we have the vertex is very easy. 2, -3. The leader is 1. 1 is positive. Yeah, it's greater than 0. So the parabola opens up. So before I even do any actual graph paper graphing, I kind of already know what I should get. I should get a parabola that opens up with its vertex at 2 and -3. Now I need one more point. So now I need the y-intercept. So just plug in x equals 0. Right here. You get 0 minus 2 squared minus 3. Negative 2 squared minus 3. 4 minus 3, which is 1. So the y-intercept is 0, 1. X is 0, y is 1. So 0, 1. Draw the graph over here. Just trying to make it fit. So 2, negative 3, that's going to be right about here. Yeah. Try to be right on the cross streets of 2nd Avenue and negative 3rd Street. Yeah. And then you have your y-intercept of 0, 1. And then you've got your axis of symmetry. I know I got a little squirrely there. Let's see. There we go. Axis of symmetry, or again, is an invisible line that goes down the middle. Are not going to graph that. This is invisible, but I want you to tell me what it is. The axis of sim is x equals 2. You can see what x value is being cut right through that value. It's basically cutting the graph in half at x equals 2. So the y-intercept is 0, 1. The axis of symmetry is x equals 2. And my graph is right here. You only need 2 points. If I were doing this on paper, I'm using a whiteboard, I'd probably put a 3rd point right there because I like to see 3 points on paper. But on the computer, you don't need 3 points. In fact, the computer is basically giving you these problems. You just plot the vertex first, plot the 2nd point, and walk away from it. You're done. After what you went through in Chapter 3, this is going to seem like a walk in the park. Okay. All right. Should we do another one? Yeah? They get worse. What makes these problems sort of a beast is if the leader is not 1. In that example, the leader was 1. What am I up to? 4, 5? We'll say 4. Graph the function negative 2 x squared minus 12x plus 6. For this one, I want you to find the vertex and then give the domain and range. Sometimes I ask the same questions all the time. Sometimes I introduce some old questions just to make sure that you haven't forgotten any of the basic math from Chapter 3. Or terminology, I should call it. All right, this one's going to be a little bit tougher. Okay. The first thing I recommend doing is rewriting your equation as y equals sometimes I'll give you the equation already as y equals, but sometimes I don't. I want you to know that, oh, if I see f of x, don't freak out. It's just the same as y. Okay? In fact, when we go to graph it, it's probably better to leave it as y. I think it makes the graphing a lot more straightforward. All right, here we go. Same steps as last time. Ready? Move the constant term over. Now here's where the techniques diverge. In the last example, I just started completing the square now, right? But you can't do that yet because the leading term must be 1. So stop. All right, so stop. Very important. The leading term must be 1.
Dr. Jordan?
Yes, hold on.
I think you went somewhere.
Okay, sorry for the interruption. Okay, so the leading coefficient, or the leader must be 1 before completing the square. All right. In the last example, we were able to go straight to completing the square. But that's because the last example was easy, right? It had a 1, or an invisible 1, in front of the x squared. So we have one more step. We're going to divide everybody by -2. Whatever the leader is, you just divide them by it. And now the leading term is 1. So now you can go on. Do the same steps as last time. You might want to notice the middle term changed into positive because it was a negative divided by a negative. -12 divided by -2 was +6. So now we're going to do the steps. You all remember the steps from the last example? If not, you can review them. You're always going to take half of the middle term and then square it. So 3 squared is 9. Okay. And now you're going to add this to both sides. All right, so we're going to put a +9 on this side and a +9 on that side. So I've got y -6 over -2. I like to leave a little blank here. You're going to need that blank spot. And then x squared plus 6x. And now we're going to add 9 to both sides. And now you're basically done. Now you just have to follow all of the steps back to where you have this in vertex form. So the next step was factoring. All of these will be factorable. Otherwise, you made a mistake over here in these if this is not factorable. Not only is it factorable, but it's perfect square factorable, which means both of the factors are perfect. Sometimes you'll get good at this. Eventually, you'll get good at this. You might already be good at it, and you jump right to here and skip this middle step altogether, if you like. All right. So you can skip this step if you can and jump right to here. All right, and now the left-hand side, I sometimes refer to this as the garage. You just stored a bunch of stuff in the garage, and then before you leave, before you submit, unpack the garage. Put everything back where it came from. So you're going to subtract 9 from both sides. Make sure when you're unpacking, you unpack in the opposite order that you packed. So when I say packed, I mean who got there. 9 got there most recently. That's the newest addition. So 9 is the first one out. The last thing you do is the first thing you're going to do on the way out. Okay. Now the -2. The -2 was the next one to show up. So you're going to multiply both sides by -2. All right. Make sure you hit everybody. 1, 2, 3 times. The only exception is the inside of the parentheses don't distribute. Don't distribute inside the parentheses. Keep this -2 outside. You do have to multiply the 9. So it's -9 times -2. That's +18. So we're done. I'm just going to copy my answer up here where you can see it. Oh, shoot. I take that back. We're not done. I forgot to move the 6. You left a box in the garage, Dr. Jordan. All right, I'll go grab that one more box. One more box. I got to add 6 to both sides. Oh, my vertex is going to be way up at 24. We're going to need a big piece of graph paper. Sometimes it's nice not to have graph paper because you can just make a mark wherever you feel like and just call that 24. So your vertex is at -3 and 24. So right here, -3 on the x and 24 on the y-axis. Which way does it point? Does it point up or does it point down? Look at the leader. Opens down. So I know I have a parabola that looks like that. So why don't we find the y-intercept and find out where it's at? So to find the y-intercept, plug in x equals 0. You can use the original function, or you can use the vertex form. It's your choice. It doesn't really matter. One of them's easier, though. The vertex form makes the vertex easy, yeah, but the original standard form makes the y-intercept easy. So I'm going to choose this one. Notice when I plug in 0 into this, this is going to turn into 0. That's going to turn into 0. So these are going to be zeros. So I'm just going to get y equals 6. Some people just memorize that the last number is the y-intercept. You can certainly do that, but I'm going to warn you, if you memorize, oh, the last number is the y-intercept, and then I give you a problem like this, and you remember that the last number is the y-intercept, you're going to get it wrong. So if you choose to memorize, make sure you memorize the whole sentence. The last number is the y-intercept if the equation is in standard form. So a lot of people forget that if part. All right. So we have our y-intercept is 0, 6. That's 24. That's 12. We'll call this 6. I know my graph's not perfectly to scale, but that's okay. I only need 2 points. So vertex, negative 324, and y-intercept, 0, 6. I think I asked you for the domain and the range. Domain is a free answer. So I don't think any of you will get the domain wrong, unless you just forgot that that's one of the free answers. Okay? I'll put that on the test. So if you remember, you get a free answer. For the range, it's not free. The range, you have to look at the graph and look at the y value. The highest y value is 24. So the range goes from negative infinity, way down here at the bottom of the graph. It's going off the window. It's going off into space. Negative infinity all the way to 24. And make sure you type it in the right way. Because if you know the answer and you type it backwards, it'll get marked wrong. And I'm going to leave it wrong because you need to write it the correct way. All right? So that is the introduction to 5.1. That'll probably get you through about 80% of the problems. I'll do some loose ends tomorrow. So Dr. Jordan is signing out. Bye-bye.